People here on a cold night and competing with Ross Garno talking at Flinders about battery storage, so you've missed out on that one. Just had some bad news that Alan Johansson, who's a long-time member, of ours, has had a heart attack a couple of days ago and is in the Lyle McEwen Hospital, hopefully recovering, but we will send him our best wishes. Tonight we've got three presenters. There's Tisham, who's telling us about his data logger. Eric, who'll be telling us about his Barina conversion, which will also include going outside to look at the Barina. And Shawn, who'll be talking about the second half of the Tesla's performance adventure throughout the east of Australia. But okay, so the first come off the right, Tisham's company is called Whatnick, and he'll tell us all about his low-cost data monitor.
Thank you. Hello, I'm Tisham. I'm going to talk more about myself later, but this is my sort of small garage venture for making low-cost energy monitors. So aside from the technology of how the monitoring is done and the data is collected, I will talk about just the small-scale electronics manufacturing that I do. So the mission that I set out on was to make energy monitoring easy and affordable. So the problem in today's market is how do we reduce the energy bills that I get. And on the side, there's a little graph for the last few days from the Australian energy market. And you can see the energy prices across the various states in Australia. And South Australia has some of the highest energy prices. And I was looking at some analysis today, and those price spikes actually correspond to reduction in wind power generation and turning on of gas generation. Dispatchable sources are actually quite expensive. And since they don't run all the time, whenever you place demand on them, the trading price of energy spikes. But South Australia has some of the highest prices anyway. My wife wanted to save a lot of electricity. The prices are high here, so she went around the house just turning things off randomly. And we had a chat that we should actually find out what is consuming the most power rather than just turn everything off. So the solution, instead of turning everything off and sitting in the dark at night, we should check what's consuming the most power, what's the worst offender, and maybe try considering replacing that if the cost of the electricity for it over the year exceeds the cost of replacing it. So I put together an energy monitor with help from friends and family. So this is the team that I work with. That's me. I'm an electronics engineer. I did my degree from Adelaide University. I tried to do a PhD, and my supervisor is here. I'm a constant tinkerer and always try to make my own solution rather than buy something off the shelf and make it easy. I have my wife there, Rani. She is a statistician and a maths teacher. She was the one who was turning things off, trying to get data in her own way. So we thought we should get some better data by actually making a data logger. And after selling a few units, I now have a young son. I couldn't make everything myself, so I had to ask for some help, and I employed a student. He's Jogan. He's known as Norm normally. He is my employee number one. He works for me on weekends, and he is also a very good programmer. Making electronics on a small scale would not be possible without the hardware facilitators that are out these days. I've got a few logos and names up there. I get my PCBs made in America by Oshpark, which is a little purple gear. In China by Seed Studio. In Melbourne by a company called Hakvana. And I get my parts from Element 14 and sometimes from China, from AliExpress, which is a bit hit and miss. So this is sort of my story, the timelines from when I started developing things and how I progressed. So in August, I built in startup world they call a minimum viable product, an MVP. So it looks something like this. So it has got a couple of analog inputs, a controller, and yeah, a Wi-Fi chip, and so on. If you can have a look at it. So in October, I managed to make a PCB and put it up on a small online shop and made my first sale to somebody in the UK. So I was pretty happy about that. Somebody actually wanted to buy my stuff that I'm making in my backyard and garage. In January, I converted from whatever I had through-hole version to an SMD version, got more PCBs made. In February, I made things a bit smaller and started trying alternative chips and so on. So basically, this is sort of trying to use my sales of the energy monitors to fund my R&D and sort of keep on making it better, I guess. Otherwise, after making one, my wife will say, "Why are you wasting time making it better? It works. I've got my data. What's happening now?" So in July today, I have had around 50 orders for my monitors from my online shop from 15 countries. I've shipped orders to Mexico, India, Singapore, US, UK, a few. And I have a growing portfolio of things related to energy monitoring that I'm sort of developing. Oops. So we'll talk about the technology, what it does, and how it's set up. So that's not actually a flying whale. It's a flying kite whale. It looks good. So basically, the technology I have is a Wi-Fi chip, a very cheap, affordable Wi-Fi chip that's being used in everything these days. It's a Espressif 8266 chip from China. They have managed to make a $1 Wi-Fi chip with a microcontroller in it. There is an analog to digital converter, and there are a lot of what are they called, Internet of Things servers, which basically let you give you a free account to push data up to them. So we'll talk about a few of them. So how does it work? It basically, I capture and digitize current and voltage waveforms, run some maths to compute RMS voltage, current, and true and reactive power. So basically capture the waveforms. If they might be in or out of phase depending on the type of loads you have. Motors will cause things to go out of phase, and you get reactive power. You draw high currents even though you're not using that much power. And then you can then take those results and use the little Wi-Fi chip to upload them onto any IoT server or your local server for storage. This slide is slightly out of space, but I can do a little demo of things anyway. So I have the current version. So this is the current version of the energy monitor that I have. I have taken the prototype that was on the breadboard, miniaturized it, added a little display, and so on. And yeah, so that's the current revision. We'll go back to the capturing and how the functioning of it works. So accurate measurements that, what I would call utility grade measurements that people can bill you on, require minimum distortion in the waveforms, use accurate voltage divider networks connected directly to the 240 volt mains, use very accurate shunt resistors, which are basically a bit of metal with few ohms of resistance. And this is actually quite unsafe for me to build and certify and sell to people because everything will be connected to mains. My monitor does what I would call good enough measurements using low voltages. So I use a clamp-on current transformer to capture the current waveform, and voltage transformer, which is your just normal AC 240 volt to 12 volt AC transformer to capture the voltage waveform. Both of these transducers will introduce phase and waveform distortions and can suffer from nonlinearities due to coupling between the mains and whatever I'm measuring. However, they are cheap, easily available, and relatively safe to use because the outputs from them that are going into my measurement device are low voltage. I think I have a current clamp here. If you haven't seen one, I'm just going to pick it up. So the sample waveforms are digitized using an analog to digital converter, which is connected over what is an I2C bus, which is essentially a 3-wire data bus. And the ADCs I use can operate up to around 1.2 kilohertz, which is sort of borderline for power measurements. There are better ADCs, but they will have to use a faster bus. This is sort of aimed at keeping everything simple and cheap, and rather than trying to go for the highest accuracy possible. The power can be computed, as I said, by multiplying the instantaneous voltages and currents. And I have been experimenting in my new version using what are called dedicated energy monitor chips, like the Atmel 8090 and the analog devices 807763. When I was doing my experiments with the Atmel chip, I realized that if I wanted to buy a pre-built test board from Atmel, it would cost me $800. So I went ahead, and the board that is going around now on the PCB, on the breadboard, it has the 8090 chip on it, and that's my sort of test for the next revision of my energy monitor using this chip. The chip itself is $2. But the development kit for building stuff on it is aimed obviously at electronics companies which do mass manufacturing and can afford to pay the $800 for the dev kit. So I have made a little breakout board for it, for the chip itself, so that people can do low voltage tests, and that has been selling as well pretty well. So that's only $15, and people around the world who are building their own energy monitors are buying this instead of buying the dev kit from Atmel to build their own solutions. So that's the last fun part. So we are using the ESP8266 cheap Wi-Fi chip, and the data can then be uploaded directly to ThinkSpeak, which is the one I use, which is, I think, owned by MATLAB. So the power of this ThinkSpeak is once your data is online, you can pay for the MATLAB engine to be analyzing all your data, performing any analytics, combining things. So you have if you have used MATLAB, MATLAB is pretty big in engineering. If you can put whole of MATLAB behind it to analyze your data if you wish to. The other little one, which is called Blink, is an open source sort of open source data platform. You can host the server yourself. You get a little app on your phone to see graphs. Let's see if I can show mine. Just give me a sec, I'll launch my app. Yes. Should have prepared this earlier. So the downside of Blink, even though it's like open source, you can host a server yourself, is that it doesn't have any analytics ability. you can grab the data yourself and perform analytics yourself. So you get like a little app like this with graphs and text and whatever widgets you want to add on top of it to have a data display. There is also a trend these days towards what is called NILM, non-intrusive load monitoring, which can perform, sorry, what's happened to the bottom of the slide? Which can perform auto detection of the different appliances you have using time series analysis. So it uses machine learning methods to analyze your appliances, because each appliance has a sort of energy usage signature. It will, some fridges typically will have a periodicity of turning on and off. That will come up in your monitoring because the data is logged every few seconds. The kettle or the microwave will have peak power usage and so on. So you actually can use this non-intrusive load monitoring technique to take the total aggregate power usage of your house and disaggregate it into all the different appliances you might be having. And they are not always on, and whenever there is an on and off event, the algorithm learns that there is a new device is being switched on. So that's sort of my sort of test and calibration, very basic setup. I didn't invest in an actual power meter. My power meter is a 110 volt bulb. I went to the Bunnings and said, give me the bulb that you have that consumes the most energy. They were a bit surprised. They were like, why do you want an inefficient light bulb? So these are some sample graphs from today that I sort of captured while I was like finalizing the slides. There you can see the laser pointer works. You can see the big energy usage spike overnight, and the power factor is almost 1 because it's like an oil heater we have. We should really use electric blankets instead. So after you've talked about the technology, you want to know about the real, how much does it cost me to make, how much can you get it for, yeah, so those things that. So I watched a really good video from one of the bloggers, the economics of selling hardware. EV blog is a very good resource. Well, I find it a very good and entertaining resource. I watch it with my 10-month-old son. And he's very, very vocal about his views and so on, and he has some good ideas. So the rule of thumb they recommend is if you want to make a living selling electronics, you can these days. Some people are making small, unique items, amplifiers for music, or reflow oven controllers, which I have bought, or you have to set the sell price at 2.5 your total cost of goods. And this is sort of my attempt at showing, depending on the design, my prices are a bit different, but on average, my PCBs cost $3 to make. Parts cost, BOM parts, bill of materials for parts is around $10. And assembly is for SMD ones, it takes longer to assemble through-hole parts, but for SMDs, I can make a batch of 8 in my reflow oven at once. It's around $2.50 for assembly. So here are some of my PCBs in my reflow oven. So they cost $20 to $30 for a batch of 10. Here are some parts that go on it. So they have total bill of materials, even getting like genuine parts from element 14 is around $10. And here is sort of my cost of assembly. So I have offered to pay him per board if he gets fast at it, otherwise it's per hourly rate, but that's sort of where this is my garage where things get built. The little oven there is that toaster oven that I bought from Kmart for $20, and I have added a little controller there which does a reflow curve. And yeah, so you solder paste and place SMD parts on it very carefully. And then, yeah, reflow it, and sometimes some parts tombstone, and they fix them up in the rework them. Anyway, so $3 to $5 per board is sort of the assembly cost. So yeah, everything gets built, and I have sold 50 of them so far. So it pays for itself. That gives me a little bit of profit to buy fun toys, electronics toys. And yeah, so I'll finish my presentation almost. So this is what is out there. There are others like Revan was mentioning fluxometer, but these are the, I guess, the lead results if you search for energy monitors on Google. FRG is, you can get them from JCar, you can get them from Bunnings. That's sort of the price range they are. They use a clamp type sensor, and they don't use the Wi-Fi chips in them yet. So you actually have to get, what is it called? This thing, which is battery powered and uses a low power RF transmitter and a Wi-Fi sort of hub, what they call Engage hub, and that will, and they also host like a fancy site with graphs and dials and so on. So that's one option. The other sort of more DIY option is the EMON-Pi, which is a big project, open energy monitor project. And I sort of use their code for performing my maths as well. So they have done a lot of pioneering work in making open source energy monitors. But the version they have currently, their top of the line version, uses a Raspberry Pi and similar current clamp and voltage sensing and so on. But it ships from the UK, and that's still fairly expensive, even though the pound is taking a pounding. And yeah, so I have my last slide, which I'll live up. Where to from here, and it's a very texty slide because it's going to be the last slide. You can just read my philosophy about the energy monitoring and why it's important and where we can go from here. Yeah, thank you. I can take any questions you have. No. The way I install my units, it's usually put on the fat wire that comes out of the main switch, and we depend on analysis of the time to disaggregate all the circuits. Mine was installed by my brother-in-law, who's an electrician. If you are planning to do the true power monitoring, as we call it, as I call it, you will need an electrician because you're working with 240 volts. If you go with the option where you power the thing out of a battery and you just use the current clamp, then you do not need an electrician. You just have to change batteries when it runs out. Putting on the transformer and putting on the mains lets it power itself, so you don't need to change batteries. That's one of the weaknesses of the FRG, that it's battery powered. It needs to be changed once in a while. Yes? Yes, could I have that, please? So I have a little expansion bus here, which is an I2C bus, so you can plug other things into it. And I actually have a friend, he wanted to wire up all of his house using what is called one-wire temperature sensors. So he has got these ultrasonic motion detectors everywhere around the house, which you get as part of your security system, and they have a 5 volt in there. So he's making a little hole in them and putting in this one-wire temperature sensors in those ultrasonic movement detectors, and they all come back and they plug into this bus. So I think he has 8 of them around the house linked up to this.
Is that hardwired?
The temperature sensors are hardwired, yes. It's a one-wire bus, and that lets it be around a few hundred meters of cable. Yeah. Yes?
What's the accuracy?
Okay, so the accuracy is a difficult question to answer. It depends on the sensors you use. Right, mine takes in inputs, so you have a voltage and current input, and depending on the sensors you use, so if you decide to be like be super accurate, you'll have to use calibrated shunt resistors and voltage divider networks. You could plug them in. It would not be safe to plug them into this. But if you use I use a 100 amp clamp, it will be inaccurate at low powers because the coupling between the wire, the magnetic field will collapse, the coupling between the transformer and the wire will be low. So I would say around 10%. So it will let you know when there are peaks and troughs, but will not be good enough to put dollar cost to bill you on it. Yes?
And I'll pass along for you to expand your business. There's a company called Enexis that was used with microinverters, and the company's gone bust.
Okay.
And all of the people who are getting the data log via the internet now have to pay $90 a year hiring cost for another company that's taken over the software control.
Yes.
Now, I don't know whether your system could read Zigbee data Wi-Fi transmission from the inverters. You might have an interesting market there with many, many hundreds of solar panels around, even just around Adelaide.
Yeah, so I'll just say why I chose to use Wi-Fi instead of any other thing. Because actually Zigbee, the standard hasn't taken over very much because the transmitters are very expensive. The transmitters for Zigbee can be up to $50 each. And so that's why Zigbee is not very popular. But I don't provide an IoT platform, right? The platform that I use is ThinkSpeak, which is provided by MATLAB. So they could go bust as well. But there are open source alternatives like Blink that you can host yourself. So I think the idea, that's why people have been adopting this, that they have the flexibility, they can do self-hosting. So they can have their own data, they don't have to send it out to a third party and then sort of, run the risk of that A, their data leaking out, and B, the third party collapsing and them losing the data. So that's why my energy monitor has had a few sales to people who want to host their own servers, want to have their own data, rather than buy something off the shelf. So if you buy the FRG product, for example, or what is the one, solar power one? Enexis one, basically you will be tied into their server. So it will be hard-coded to talk to their server, and there will be no recourse if they decide to sort of start charging for it or lose the data or leak the data. So the energy monitoring is actually very sort of sensitive topic because if the data becomes available to people, they can see when you're not at home, for example, that your power usage is low, and so you need to sort of be aware that these things can happen and have your Wi-Fi network secured, have your data channel secured, and so on.
So is that Wi-Fi secure? For example, on a router you might have a password. Does that have passwords?
Yes, yes. So the Wi-Fi node uses WPA security, so it has, and also the upload uses HTTPS, so that channel is secured, but then ThinkSpeak password can be lost here, you know. So if you want to be fully secure, you're better off hosting your own servers within your house.
Remind us, you're the finalist in the South Australian
Zero Carbon Challenge. So Adelaide Zero Carbon Challenge is an initiative by the Adelaide City Council to reduce the carbon footprint of Adelaide as a city. I entered my thing to monitor all the office buildings and the large sort of towers within the city to see how much energy they're using, to have metrics, and they can try to get to zero, but there is no way to prove it unless you measure it.
On that very point, I know it's outside the scope of what you're telling us tonight,
Yes.
but when they talk about zero carbon, blah, 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 they're only looking at the variable cost. They don't look at the fixed cost of all the equipment and the carbon used to make them.
Yeah.
So it's a totally distorted picture.
Yeah, solar panels and stuff and windmills. Oh. Yeah, everything takes carbon to be made. You cannot make steel without carbon. Yes.
So I need to know your website and how we get in touch with you.
Okay.
Where's your advertising?
Yeah, I'll go back to my beginning. I haven't put any advertising because, if people are interested, you can, reach me. My website is whatnick.com. It leads to my blog, which has got all the sales stuff on it. So yeah.
well, next, and incidentally, of the Zero Carbon Challenge, there were 175 entrants, and Tisham is down in the final 10, so that's quite an achievement. And the final will be in October, I believe. Yeah. Okay, the next presenter is Eric to tell us about the Barina. He's converted, and after his presentation we'll go out and...
After the next one, after
after Shawn, yeah. So at the very end of the evening, when you're grabbing a cup of tea, we can go and have a look at the Barina. So please welcome Eric.
Thank you, Alan. Now tonight I'm talking about my conversion of my Holden Barina. Actually, I started converting it back in 2008. And it took 2 years for me to do it, and the reason it took 2 years you'll see in the presentation. There's a couple of things which I couldn't make myself, and I had to wait on someone else to make them for me, and they were doing them sort of in their spare time so they could give me a good price. So I'll continue. Why do it? There's a lot of reasons why people might want to convert a car. My main reason was I had an interest in electronics and also an interest in cars. So putting the two together, I thought that would be a great idea to do. And just before I started the conversion, I actually went and visited a couple of guys down at Goolwa who had done it about 2 years before that. And I got to drive their cars that they converted, and I fell in love with the idea. And straight after that, I actually went and bought my own little car, a Holden Barina, and started converting that. Now you've got to remember, 2008 was before any electric car was available in Australia. So the problems that I had was I didn't know what size battery to put in it. I sort of theoretically worked out if I had a certain size, I'd be able to go a certain distance. But even that was sort of a bit puzzling at the time. Of course, now if you wanted to do it, you could compare Mitsubishi i-MiEV or a Nissan Leaf, something like that, to get what size battery they've got and to see how far they go. But back in 2008, I had no idea. But what I basically did was I looked at the size in the back of the car. I wanted to just use where the back seat was for the batteries. So I looked at that space and worked out from there how many batteries I could fit in, and that was basically it, and what size batteries would fit. I wanted to leave a bit of room in the back for luggage and stuff. Now that picture there is just a typical electric conversion. It's off a website from Western Australia. That's got batteries in the front and the back. Mine's just got batteries just behind the front seat where the back seat used to be. There is a lot of little bits and pieces. There's motor controllers, other than the battery pack, motor controller, contactor, fuse, circuit breakers, power brake, vacuum pumps, DC-DC converters, instrumentation, power steering pump if you've got power steering. I haven't, luckily, and also a battery charger. So you carry a battery charger around so that if it's convenient, you can plug in anywhere. Anyone that's got a 240 volt outlet, you can plug in to charge your car. So this is the car. This is actually a photo taken in 2010, just after I finished the conversion, up against the fountain in Victoria Square, where it was then. Now you can't park next to it now because it's right down in the corner. They shifted the fountain. So there it is before the conversion. So the thing to do is to get rid of all that smelly old petrol engine and anything to do with petrol, like the petrol tank, the exhaust system, radiator, and all that stuff. It was just so much stuff to get rid of. So 57 kilograms was the size of the motor. I thought, before I started taking it out, I thought, oh, this is going to be great. I'm going to take out this engine and put a nice small electric motor in. But it only weighed 57 kilograms, which it's all alloy. Little 1.3 litre engine, it's all alloy. You can just about lift it yourself, you know. but I used a hoist. So there it is, it's all gone. So you go from that to that, and it didn't take very long to do that. I just disconnected everything basically around the engine, borrowed a hoist, and hoisted it out. It went that quick that I forgot to take a movie of it. I got a movie of most of the other stuff, but it just sort of came out, and there it is on the garage floor. So I had a nice chance then to clean up the inside of the engine bay, got rid of all the grease and all the oil, and just gave it a bit of a light respray of the same colour. This is one of the things that I mentioned that I can't make myself. There's another picture later on showing the motor on the gearbox. So you use the original gearbox basically. That way you can match your speed to the engine revs and use it basically like a normal car, except in this case the clutch is left out. I didn't use the clutch in this conversion. So we start off with a blank piece of steel, and Ray Hammett from Hammett Precision Engineering, a lot of people here might know of him. He actually made the adapter plate for me, and when it was finished it came up like that. So it went from 20 kilograms to 6 kilograms. So beautiful job, it just all turned on the lathe. If you go to my website, I've got some cards, or you can find my website from the electric vehicle brochure at the back on the back table. There's a video of that plate actually being turned in a lathe, being made. It's quite fascinating watching it being done. And it was people often ask, why did you use steel rather than aluminium? Aluminium would be lighter. Well, yeah, aluminium would be lighter, but you'd have to make it thicker. And also, Ray liked machining steel. Steel was a lot easier for him to machine than aluminium. It's a lot easier on tools and so forth. So there we have the adapter plate is actually on the lathe there, and he's just put the motor up against just to check to make sure it's all going to be in alignment. So that fixes the motor to the gearbox, but inside you have to connect the input shaft of the gearbox back to the motor. So what we do there is another thing that Ray made for me was the coupler, and that's also made out of steel. It's actually made out of a steel that they use for crankshaft, which is a very, very, very strong steel. Now, to connect to the motor, what I did, this side here, this side here connects to the motor, and then this side here, I use the centre of the clutch plate. This bit here, it's just the centre of the clutch plate, and of course that's got the spline in here which goes on the input shaft of the gearbox, which was very handy, so you don't have to have a separate spline, since you use the original spline which came on the clutch plate. So this way I've used the springs in the clutch plate to take up a little bit of the high torque that happens as you put your foot down. And here's the motor and the gearbox going back into the car with a little crane. So the motor weighed 37, the original engine was 57, the motor is 37 and the gearbox is 27. It's handy how they're all sevens, I don't know how that happened. So there you can see it, the adapter plate sits nicely down there. And of course, when you're choosing the motor for the conversion, you've got to make sure it's going to fit in the car. So you sort of have to work out before you order the motor that it's going to fit. In actual fact, it comes very close here to the side of the firewall. and you can't cut pieces out of the side of the engine bay. You're not allowed to do that because it weakens the car. So yeah, there's only about a gap of 50 millimetres from the end of the motor to the side of the engine bay.
Can I ask where you got your electric motor?
Electric motor was from a company, just EV Motors in Sydney. It's actually an American ADC motor, advanced DC motor, made in, I think it's in New York, or now they're making them in Mexico somewhere. It is a 6.7 inch motor. I've got all the specs later on. It's a fairly small motor really for an electric car. And it's a brushed motor, so it's a DC brushed motor. The good thing about DC motors is a lot of people might know that they've got very high torque. So you've got from 0 RPM, you've basically got full torque straight away. So there's no problem getting away from the lights. That's an underside view of the motor on the gearbox. So you can see the adapter plate. See the adapter plate here, the gearbox there, the motor there. This is the other end. You can see how close it is to the side of the engine bay, and a little bit of that space is taken up by my tacho sender. So it's just a steel block with a gap in it, and I used a Hall effect device to sense the gap, and that gives two pulses per revolution, and it makes my original tacho show the motor revs rather than engine revs. A little bit of trickery had to be done there. I had to make up a box to go from the low voltage DC pulses up to high voltage DC pulses to power the tacho, because the original tacho was powered from got its signal from the coil, which had some 150 volt spikes and things running around. So I had to reproduce that with a transformer and a transistor and so forth. This is what happens when you're sort of in the middle of a conversion. You've got wires everywhere and there's tools everywhere, soldering irons and heat lamps and heat shrink. Now, with an electric conversion, one of the things that Regency look for is the fact that you've got a demister. You don't have to have a heater, but your demister has to work. And in my case, when I got my car checked at Regency, he actually did ask me to put my demister on, and I did, and it was very, very hot. And the reason that is, it's actually an electric heater, and it's a ceramic element. What I did, the original heater core, which you can see there, I cut the middle out of and used some high temperature silicon and put the 110 volt ceramic element inside the original core. So that goes back into the original heater box in the car. Now the heating element I got out of a heater that I bought on eBay from America. So I bought the whole fan heater from America and took the element out of it and chucked the rest away. There's a gentleman now in America, a young guy who I spoke to about this after he had his conversion on YouTube, and he now sells just the element from the heaters that he gets from Walmart. So anyone who wants one can just buy one, just the element from him, which saves you a lot of money. But it does get very hot. I use it as a heater and also as a demister. It actually goes through exactly the same paths as the original heater. So you use the same levers and everything. But I have put a micro switch on the heater box on one of the arms, so that it will only work if you've got it in the heat position. The element won't come on if you've got the flaps in a certain position where it actually blocks off the heater box. In that case, the element might overheat and cause a fire. So there's a sort of a safety switch on there. Okay, from the batteries, you have to bring the high voltage cables to the front of the car, and what I've done there, I've just used conduits, orange conduits, and brought the wires through and then underneath where the exhaust pipe used to be and up to the front of the car. And that's where you can see them there. That's coming, that's going up to inside the engine bay. Another one sneaks up in here somewhere. So I'm running about 130 volts, so you've got to sort of make sure it's safe. And also normally any orange cables, the people who look after ambulances and so forth, they always look for orange cables and make sure they don't cut them. So it's a good thing. This is the beginning of just after the battery frame has been welded. So a little bit of work designing that. We've got 3 rows of batteries, which I'll show you in a sec. So that was sort of all welded up for me. I don't do welding myself, but I got a friend of mine to help me with that. And then I got it zinc passivated. Instead of painting it, I thought I'd get it all zinc passivated. And while I was doing that, there was a whole lot of other steel that I was using in the front of the car as well, so I got the whole lot done at once. And the people that do the passivating have got a minimum charge, so it was you chuck everything in that you think you might want to get plated. So I did that. And you can see the holding down holes here, and there's some across the back. I think this is probably the front. The front ones I actually had to put in new holes through the floor, and to do that, when you do that, you've got to put plates underneath. So you have a plate that sort of stops the bolt pulling through from underneath. And the Regency actually specify the size of those plates, and you've got to make sure the corners are rounded off as well, so they're not dangerous. So they got passivated as well, which was good. And it just so happens that's the front, and the rear of the battery box is held down by the seatbelt mounts, which were originally used for the back seat. And they've got an incredible safety rating on those, so there was no problem getting that passed through Regency. This is one of the cells. There's 40 cells in this car. Each one of them is 3.25 volts and with a capacity of 90 ampere hours and a weight of 3 kilograms. Yeah, so the whole battery pack is, I think with the steel, it's just under 150 kilograms, which is not too bad. It's about the same as a couple of people sitting in the back of the car. So the batteries are sitting where the people were sitting, could have been sitting. The batteries weren't mounted like that. They're actually mounted vertically with the terminals on the top. You can actually mount them like that. That's one of the other ways you can do it, but you can't lay them flat. If you lay them flat, this particular one, some of the newer ones you might be able to lay flat, but I know of 2 or 3 people that have had problems when they laid them flat, so you don't like that. On each cell, that's the top of each cell, with a battery management module from EV Power in Western Australia. I've actually met the guy last year. They had the AGM for the Electric Vehicle Association over in Perth, and I actually met Rod Dilks. He's sort of in charge of, that's his business, EV Power, and he actually designed these boards. He sold a lot of these things. Even when you look at some of the cars in America that have been converted, they're using his modules. And so there's one of those on every cell. So there's 40, and those black wires there, those little black wires, you run a loop from one to the next, all around the 40 cells. So you end up with 2 wires, and they go back to a controller. And then what happens is, if there's a problem, the loop opens. Each of these cells has got the capability of opening that loop. So if a cell goes low or a cell goes high, the loop opens. So in each of those cases, the controller handles whichever one it is and does what it does nicely. The under voltage works at about, I think you saw it was 3.25 per cell nominal. If it gets down to 2.5 volts or below, it opens the loop and you get an alarm from your controller box, and that one's just sitting behind the front seat. If you have a over voltage situation, the loop opens again, and if it does that, it actually turns the charger off. So it protects your batteries and you don't have fires and so forth. Since I built the car, since I finished it in 2010, I've never had the alarm for low voltage, and the high voltage hasn't happened since the pack has been balanced, and it took about sort of 3 or 4 months for the battery pack to balance properly, all 40 cells, and so the charger doesn't even get turned off by the BMS anymore. When it first was installed, one of these would get to about 4.25 volts, or about just over 4 volts, and it would turn the charger off. But then once all the cells balance, they get to about 3.69 or something like that, and then they're all the same, and the charger turns itself off nicely, which is good. So there's the 40 cells all sitting in the frame where the back seat used to be. So there's quite a little hollow there. You can see that there where the back comes up. This is the back of the car here. So you can see that comes up fairly high. So it drops down where the back seat was into a hole. And you can see those bars across the top. When I was working with the engineer, when you do these things, you've got to work with an engineer who then, at the end of the thing, he gives you a report which you take to Regency. And I sent him pencil drawings of what I was going to do, and he said, yeah, that's okay, as long as you put some diagonals in. So you can see a couple of diagonals there and a couple of diagonals on the front to make it stronger. And then he said, well, how are you going to hold the cells down? Because you can't have cells coming out when you're rolling the car over. So I had to devise a thing which I sort of cheated a little bit. I saw that there was another car in Perth that was converted in a very similar method, so I just used these steel angles. You can see them going across the top here. And each of those has got a plastic block holding down 4 cells. Each block holds down 4 cells, the corner of 4 cells. And it does it very nicely. I haven't had to test it with the car rollover, which is good. You can see lots of tools there. So there's the charger. It's an Italian charger, the one on the left. Big grey box there. It's been running all this time, the whole 6 years, and there's been no hiccups. It just does its job, and then sits there till you want to use it again. And there's a little 12-volt charger there for the 12-volt battery. The 12-volt battery, of course, runs all the normal 12-volt stuff, all your fans and radios and lights and stuff like that, as normal. So that keeps that charged up. It's a deep cycle battery, so you don't have to start an engine anymore, so you don't have to have high power starting currents and things like that. But that keeps that charges up each night. When I plug it in, both chargers come on, so the battery gets topped up each night. Even though I'm using a DC converter as well during the day. So then I got a nice bit of carpet made to sit on top of the batteries, and they basically disappear. A little bit of a rise. But, it certainly left me a lot of space that I can use for carrying stuff around, especially for the EV meetings where I've got to carry banners and flags and all sorts of things, TVs and stuff like that. So underneath you're supposed to stop it being splashed. So I organised some aluminium sheets. I used cardboard at first, but the old trick of making it out of cardboard, then just transfer your cardboard to the aluminium and cut it out, and that worked quite well. It's not sealed completely. There's a little hole there actually where the bit of the gearbox sneaks through down here somewhere. Yeah. But it stops the motor getting splashed, and readers here like to see that. So there it is now, with all the bits and pieces. So you can't see the motor very well. If you look down, right down, when you have a look after, you can look right down here and see the end of the motor with the little sender for the tacho on the end of the motor. So what we've got motor controller here. You can see the heavy 50mm square cables going in and out of the controller there. DC-DC converter to keep the 12-volt battery topped up as you're going along. And various other boxes. There's a box here which just brings all the wires out from my centre console. So I can actually, instead of getting behind the console to change things, I can change it there, which makes it very easy to do some rewiring if I ever need to. Little box back here to control the heater, and it goes up and controls a electronic relay to switch the high voltage line to the heater. And all the high voltage lines, even the low current ones, are all covered in orange heat shrink, just to let you know that they're high voltage. And you have to put signs everywhere to warn people, so there's high voltage signs everywhere. That little box back there is this contactor, the main contactor, which the power goes up from the battery. That's the first thing it goes to. So when the power's turned off, it's pretty safe. The whole lot's pretty safe. Next one. Here we go. There's a few stats there for you. The battery capacity is 12 kilowatt hours. I think the iMEV was 16. And I think the Leaf is about 20. So you can see it's a fairly small battery. I can get about 80 kilometres if I leave 20% in the battery, so you probably could, if you needed to, you could probably get close to 100 kilometres. And it's only theoretical. I've never actually tested it for range by letting the batteries go down and having the alarm come on. But 80 kilometres does me. And I've got gauges in there. I haven't mentioned that on here or in the talk. I've got a gauge which shows the ampere hours used, so you can actually keep a track of that as you're driving. And also it shows the current and the current voltage as you're driving, so you can keep a bit of an eye on that. Before the conversion, the car weighed 740 kilograms. That's a very, very light car. I think the Barinas these days, they start off around about 1,500. And then after the conversion, it was only 80 kilograms heavier, at 820 kilograms. Motor controller is the Ziva MC600S. That's made by a gentleman in Western Australia. And they're sold through, his website. Ziva, that's right, ziva.com.au. And mine was one of the first that he'd made. Before that, I had another controller which I borrowed actually from him as well. But it was supposed to be a 500 amp controller, but it would maybe do 500 peaks for a fraction of a second, but it definitely didn't do 500 amps. And it was very embarrassing driving with it. Taking off from the lights, you wouldn't be able to keep up with the traffic at all. So I soon got rid of that and got this Ziva one as soon as he had that ready for me. The motor is a DC motor, ADC X91 4001, normally 120 volts. They will take up to 144 volts. I'm feeding about 130. 15 horsepower nominal and 55 horsepower peak. The electric motors are always nominal power because they class that 15 horsepower is actually 1 hour of running. It'll do that, 15 horsepower for 1 hour. So if you're driving this car for 1 hour and you're using more than 15 horsepower, it gets hot, so I had to put some fans on the motor. One fan on the motor and a couple of fans on the controller to keep the temperature down. And it's only then you need it when you're doing a long trip. I actually did one before I had the fans. I had the motor give its over temperature light a couple of times, which is a warning. I think that comes at 120 degrees C, and the motor insulation will go to 140 degrees C. So if you see the light come on, you basically stop. Batteries are Thunder Skies, Lithium Iron Phosphate. I think they're about the second issue. The first ones were white ones, and they had a few problems with them, and then they redesigned it, and they come up with these yellow ones. And I've had them, like I said, for 6 years, driving it for 8 years. No, 6 years. That's right. I've had the batteries longer than that. Actually, I bought the batteries when the dollar was fairly low, which is a bit of a pain. Way of the car, 80 kilometres. The speed, it'll do the normal speed, whatever the car did before. It'll do 100 kilometres an hour, no problems. You just drive it like a normal car. Like I said, it hasn't got a clutch. There's no problem there because the motor itself's got no weight in the thing like a petrol engine's got. So you basically just take your foot off the accelerator, take the load off, and then just pull it into neutral, then just drop it into the next gear. And there's no crunching, no nothing. So it's just like a switch. You just drop it to the next gear. Going back a gear, you can put it into neutral and just give the engine a little bit of a touch, just to rev it, motor a bit of a touch, rev it up and just drop it into the gear. But yeah, you don't get any crunching or anything like that. And of course you can pull up to the lights in whatever gear you're in. There's no clutch to put in, and you can't stall the motor. And often I'll pull up in fourth gear, and then you go to take off, haven't changed back, because I normally take off in second gear. So then you sort of got to try and, you can take off in fourth, but if you try and do it too fast, you draw a lot of current, because of your gear ratios, you're trying to get this weight moving in a high gear. So you try and drop it back to at least go back to second or third. Can take off in third. I know of other people who have converted similar car, maybe a little bit lighter, and he's used just third gear and fourth gear. He's actually physically disabled the first gear and second gear. So he just uses third and fourth and reverse.
Here are two quick questions. When you come to the lights, you can just take off the touch, obviously.
Yeah.
Reverse gear is at the top and the second question.
No, reverse gear you still use the gearbox.
Okay.
Just straight back into reverse.
And will the car go just as fast in reverse?
Actually, that is a problem because reverse gear is very, very low, and like I said, I don't use first gear except if it's a really high. Someone's got a really high sharp driveway to go up. You can use first gear, but it's very, very low ratio, and reverse is the same. And I had to make a special box to reduce the drive to the motor in reverse gear. So it actually drops it right down, and otherwise you put your foot on the accelerator in reverse, it's just too touchy, and you're just so dangerous. So you just drop it down to about I think it was about a third of the voltage going to the motor, and so it's just very, very smooth takeoff in reverse now. So there it is with a new paint job and a decal, zero emission. That's it. So there's a website. There's a website if anyone wants to go there. There's a lot of videos on there that I made through the processes of making the car and after driving the car as well. And there's also a lot of information about the process of converting a car. But all the different stages and all the forms you've got to fill in and get and do and take with you when you go to register your car and stuff like that.
So what are you servicing in your maintenance requirements?
Charging, servicing.
You said your motor was a brush motor.
Yeah, I did have a problem with the brushes. I shouldn't have. The brushes should last for 30, 40 years, but for some reason, the top brush, there's 4 brushes, or 4 sets of 2 brushes. There's actually 8 brushes altogether. And the top set wore down right down to the copper wires that go in there, and the copper wire was actually rubbing on the commutator and making a racket. I didn't realise what the racket was at first. I thought it might have been my constant velocity joints. I found out it was the motor itself, and I had to actually get new brushes made up. I tried buying original brushes, but no one could sell them to me. So I actually got some new brushes made up by a place in Queensland, and they actually put the curvature of my commutator on the brush as well. And I've had them in now, and I've probably done more kilometres now than I did with the originals. And but when I put them in, I actually bedded them in by running there's a video on my website showing that. And I bed them in by putting it on a 12-volt power supply and ran it, and it took 270 continuous hours to bed the brushes in.
For full contact.
For full contact. I took them out every now and again. You can see the wear, and it's on the video. You can actually see the amount of wear on it. Even though they put the curvature on there, of course, with the brush doesn't sit exactly perpendicular. So it had to actually wear away more of the curvature to match the commutator. And yeah, 270 hours, and I did a graph of the noise level, and you can actually see that the noise level drop down like that as time goes by. And yeah, so I don't know. I still don't know to this day what was causing the brushes to wear out. There is a point that they might not have been actually bedded in originally, and by not having them bed in, that can cause a lot of problems, because there's only a very small contact area in the beginning if they're square. The original ones, if I had have got them, they were square, not curved to the commutator. So they might not have been bedded in.
So that entailed you then taking all that stuff on the top of the motor out?
Yeah. I've got. It's not that hard. You'll see it after. There's a plate on the right-hand side above the gearbox, which has got a whole lot of gear on it, and another one above the motor, which has got the controller mainly. So that's basically just a few bolts and a few connectors, and lift that out. Yeah. And the controller is from the accelerator. Uses the same accelerator cable, and it goes onto a Hall effect hot box, as they call them, and that then sends a 0 to 5 volt signal to the controller. So all that had to come off, and luckily I didn't have to take the motor out. I could get to the motor. You take the cover off the commutator, and I could get to all the brushes that way. So they all came out and all got replaced, all of them. And because the other ones were worn down about halfway, but I don't know why these top 2 were worn out.
So Regency don't have any requirements for specific maintenance or checks?
Oh no. Regency mainly are there to check your car is roadworthy. And when they when they open the bonnet, they go, come over, look at this, come over, look at this. And all the guys come and peer in. But then they just check, you make sure all your brake hoses haven't got cracks, and they check your bearings and stuff like that, all the normal stuff. And they basically have to accept the report from the engineer. The engineer writes the report saying, yes, the batteries are held down in a way that they will withstand 10G, 15G, 20G, whatever it is, before there's a problem. So basically they just tick it off from that. Yeah.
How many Ks have you done since the electric conversion?
About 25,000.
And how would you rate the wear level on the batteries?
I haven't noticed any degradation at all. Yeah, I still get 80 Ks. So It's they reckon that theoretically you get 10 years out of them. That was what it was when I bought them, but who knows? Another 4 years, we'll find out. Yeah.
So roughly how much did you end up spending and how many hours did you end up?
Well, that's a good question, isn't it? Number of hours, I've got absolutely no idea. Lots of hours. The cost of all the gear, like I said, I bought the batteries when the dollar was the lowest, like 64 cents or something. And they were about $9,000 just for the batteries. The controller's about $1,500. The motor was nearly $2,000. The car was $1,000. Cheapest part of the car. But yeah, probably all up around about 20,000. Yeah, it's not a cheap thing to do, but it's just worthwhile. You know, I love doing it and love driving it. Any question?
How does an actually behave, like cornering, things like that, different weight distribution compared to the old car?
Very good. Yeah, most of the weight is fairly low down because it's right down on the bottom of the body. And yeah, the handling's very good. It's actually probably the handling's probably better than it was. The front to back weight ratio now is closer to 50-50. Still heavier at the front, which is amazing, but the batteries are between the wheels. Yeah, it's still heavier at the front, but it's getting closer to 50-50. So I think it's probably better than it was before. Yes?
Did you have to change the suspension at all, like increase or decrease the spring rates?
No, I didn't. It was amazing. It's got leaf springs on the back, and it handled it very well. The only thing I did have to do was just put new shock absorbers on because the old ones were worn out. But no, I didn't have to do anything with the springs.
Brakes the same?
Brakes the same.
And did you...
I would have liked to have better brakes. They're disc on the front and drum on the back. But we can't do a lot for it. I actually went to the brake guy and asked him if he could make it better, and he said I can't really improve it much. But they're good enough.
And did you explore the option of an AC motor?
I'd love to do another conversion, and if I did another one, it would be AC. Yeah. When I made this one, there wasn't a lot of high voltage AC motors around. The highest one at that stage was 100 volts, and I wanted to use more than that. But now you can get there's a much better range of electric motors that you can buy up to 144 volts.
I was going to ask you about the motor. When you say doing 80, what's your motor revving at in your car?
80, about 3,500 revs.
The other thing about the motors I wanted to ask you was, there are a lot of AC motors around now. What's the advantage of AC over DC?
AC, you've got regeneration on your braking and decelerating. That's one of the big problems with the DC motor. Going down Shepherd's Hill Road, you've got to brake all the way down. So you take it down, brake just below 60, let it go just above 60, then brake. The brakes get quite warm. With the regeneration, you don't have to brake at all, which is pretty amazing. Yeah. Any more questions?
What have you got where the fuel tank used to be?
Nothing where the actual tank was, but where the filler was, I've got a 240 volt socket, like a caravan. Plug. Yeah.
How do the brakes work? Because normally you use the vacuum of...
Good point. One of the slides there showed the basic things, and it had a brake booster, and it's an electric vacuum pump you have to purchase and add on, and that goes in place of the engine vacuum. And the one I used was made specifically for electric cars, and it's got built-in pressure or vacuum sensor to turn it on and off when required, and so you don't have external anything to it. You just basically put it on, put 12 volts on it, and it works. That keeps the specifications actually match the original car very, very well. And in part of the process of showing Regency what I'd done, I actually put the specifications for that in the folder so they could actually see that match the original. So there's no problem there. Yeah.
Does anybody convert automatic transmission cars, or does that
Not,
really
not a
work?
lot in Australia, but in America they do a fair bit. You've got to use a particular type of automatic transmission, and then you disengage the whatever it's called, torque converter. Yeah, but yeah, they've done it in America, but I think it'd be a little bit inefficient still. You better get that direct connection. That's all. Yes, great idea.
See how many things I can do at once. All right, hello. My name's Shawn Zeppel. I did a little presentation 2 or 3 months ago on a Tesla that travelled all the way across Australia. So some of you may have seen it. I'll do a quick little recap on the presentation, and then I've got some numbers of his actual completed journey. So essentially, Matt Kemner decided to take his Tesla Model S from Perth, where he lives, all the way across Australia, down through South Australia, into Melbourne, Sydney, and up to Brisbane, and then back again. Why? Because he's crazy, and also to prove it can be done. So this was a little bit in association with the Australian EVA guys to prove that it could be done, to contact places to get charging stations set up, and also for a holiday, you know, the journey. So just a quick little recap. That's Matt and his Tesla there, and he gave the trip a little name, Nullus Arbor Unum Tesla, which was 0 trees, 1 Tesla, for the big plains trip. That was the hardest bit, getting from Perth to Adelaide, obviously, because it's the longest journey. He provided live tracking so everyone could actually watch his vehicle live via GPS across the map to see how he's doing, and he then also rigged that up because the Tesla's got a lot of software in it, battery level and everything, so you could see how fast he was going, how much battery had left, etc. Multiple charging devices, because every different place had a different outlet that he was working with. As I said, the live tracking, and we could literally see different little points. His Tesla had the autopilot hardware, that's the lane guidance and speed checking, everything else enabled, and so he absolutely loved it. Some of the roads in outback Australia weren't too good because line markings and contrast and everything aren't fantastic, but generally speaking, it was fantastic and made his trips a lot less tiring, because you don't really realise it, but when you're sitting at 110 k's an hour for 4 hours straight, you're quite tense holding the wheel. So he could then stay a lot more alert because he could just focus on the road, letting the car keep itself in the lanes and watching out for anything else. So he was well rested essentially when he arrived at his next destination, whereas we would normally be completely stuffed. So he's done quite well there. As I said, contacted a number of places to get charging points installed. One of the key ones was the Nullarbor Roadhouse, which they got a charging point installed and a sign put up that it's a key spot. Obviously not going to be many people going through there in electric vehicles, it's a fair way out, but a good starting point. And then hitting here in Adelaide to do his charging on the Chadmo charger. That was one of the higher current chargers he used. And met up with another traveller over in Melbourne who was doing a similar trip but in a Nissan Leaf, of all things. So he kept a generator in his boot because a couple of the trips he doesn't have enough range for. So yeah, there was plenty of information on his website. So a couple of the bits that I wanted to add were feeds off of his Twitter that you can still go back and look across everything at TransOzTesla. but essentially some of the numbers he finished up with. So, don't know whether I can get that any bigger. 13,000 kilometres to make his way from Perth down through to Adelaide, across to Melbourne, up to Sydney, up to Brisbane, and then back again. So a fair trip in his car, a total of 2,600 kilowatts required to get his car there and back. As you can see, there's a little trip meter that he's put in there. His total since he's purchased the car, and then the average energy. So in his Tesla, given the entire trip, he was using an average of 206 watt hours per kilometre. So obviously a lot of country driving in there, but a good indication on what the Tesla can do. His is the 90 without the performance pack or dual motor, so it's a single motor, but gives people a fairly good indication. But one of the bits that was of interest is he met up with a few other Tesla owners along the way, and they went for a drive in the hills, and he has the performance model. I've just got to find it here. I didn't get enough time to pre-prepare for this, so I apologise for some skipping and bobbing. But they took two cars in the exact same that's good journey, and were able to compare the energy usage, because everyone just looks at singular cars in terms of energy usage. There you go. So a good little thing. He has the P85 Plus with the 21-inch wheels, which are slightly more inefficient. And he had a friend's 85 with the 19-inch wheels, and it was about 15% more energy required to drive his vehicle. That's just having the slightly high performance motor and the larger wheels. So, wheels and motors do make a reasonable difference if you're getting right down to the nitty gritty. 15% can be the difference between getting to your destination and not if you're doing a long drive. So that was quite an interesting point, but certainly wasn't without its nail-biting moments. So one of the trips he did do, according to the Tesla range, which of course does have slightly more than zero. If you get to zero, there's still another 20 kilometres or so. But they got there with 3 Ks of typical range remaining due to slight detours on roadworks and, of course, headwinds, which impacts it. So the Tesla has a pretty good idea of the terrain throughout Australia in terms of it planning its trip, but certainly wasn't without the cutting it close moments. We were watching this one in particular, a few of us going, the battery remaining says 0% and he's still driving, so he's got to be close. So he didn't ever actually run out, thankfully, but he got himself close. So Matt made it there and back without a hitch. He met up with people at the Tesla stores in Melbourne and Sydney to encourage them to put some more destination charges around Australia, but alas, nothing came of any of that yet. It's interesting, there's actually more Teslas, I think, in Perth than there is in Melbourne at the moment, but they've got a Tesla store, so, and the high charges. But one of the interesting parts was the day he arrived back in Perth after just doing his huge trip, someone on Sydney Morning Herald posted an article saying that it'll be decades before EVs can cross the Nullarbor, which he just completed twice. So he tweeted the article back just to say, hello, it's just been completed. So obviously it's going to be decades before mum and dad can just pick up in their minivan and head across in an EV, but it's certainly doable now. So he thoroughly enjoyed it. I don't know that he's planning another trip anytime soon, because it's a lot of time and money investment, but I think he said this is going by memory, but the total cost to charge the vehicle was less than $200 worth of electricity, because obviously some places provided it for free, some he paid. But the biggest issue he had was a lot of places just not quite knowing what to do exactly. There's a charging point. Do we charge you? Is there a cost? I'm not quite sure, because they don't know what to do. When you rock up at a hotel, they let you use the PowerPoints because you're just going to charge your iPhone or whichever your laptop. That's not a problem. But when you rock up with a vehicle that's got an 85 kilowatt battery in it, they're a little bit concerned. So quite a journey, very interesting. Charging at the back of the laundry mats where they had the higher current outlets, charging in the middle of a park, off the edge of a sports field on a light tower, because that was the only spot they had a 3-phase outlet. So very interesting, good little journey. As I said, you can always check out his Twitter feed, because it's got all of the photos, and feel free to ask him questions directly if you have any questions as to where he charged and how it was all done, etc., because we want more people to try and achieve this, because that then obviously allows more charging points in more remote locations, because eventually we'll all be driving an electric something, so the more available charging the better. And hopefully Tesla will put some charging superchargers here eventually. I believe they're doing Brisbane next, and then they're going to look at the Melbourne to Adelaide route, so the next few years hopefully we'll see a few more Teslas driving between Melbourne and Adelaide on some superchargers. So here's to doing a quick charge all the way through to Melbourne.
How long does it take to charge on a supercharger?
Oh yeah, we had a picture in there. So the your three-phase outlets were 30 amps or thereabouts. To charge, your typical in-house chargers are 12 to 15 amps, but the superchargers are in the order of 90 to 100 amps. And he had a picture of one of the superchargers showing just how much ridiculous current these things are pushing through when he actually landed, because he'd never actually supercharged in terms of using the superchargers before. Because he lives over in Perth, there are 0 superchargers up through there, so when he arrived in Melbourne for the first time, he was quite excited to actually plug it in and see. Here we go, my first supercharger. Let's see if this thing shows. There you go. So 277 amps at 351 volts to charge from basically 0 to nearly full within an hour. So phenomenal amount of current going down those wires, but not something you'd want to accidentally cut off. Or something you can easily install at home either, because I don't think the utilities would be happy bringing in a whole Stobie pole to your house just to charge your electric vehicle quickly. But the idea is you don't need that at home. You've got the 8 hours overnight to charge a vehicle. It's for the quick stop at the shops. Plug in, it'll top you up. Obviously, like all battery chargers, your 0 to 70% is the quickest. So if you keep yourself within that sort of range, you can quick charge and away you go. But phenomenal numbers when you start thinking about your own little electric cars. You're plugging in at home and you go, I'm at 130 volts, and this and that, that's all right. And you turn around and realise this is, melt you to pieces if you put yourself between it. It's just scary stuff.
Supercharging, does that affect the battery life at all?
So the question is supercharger affecting battery life. Not that anyone has found yet, but again, the Teslas are still in their infancy. Some of the original Roadsters, they're not supercharger compatible. They didn't have the higher current chargers in them, but the batteries in those haven't really shown any degradation. The oldest Tesla Model S's are, what are we now, 4 years? So it's not really enough, but all the predictions are like the other Barina's showing. The degradation has all been predicted numbers, and everyone's just showing these batteries are just going and going and going and going. So they'll warranty them to a certain point, but in terms of actual lifespan, they haven't come up short yet. But we don't have enough history yet either. All the older electric vehicles are old lead acids, so you can't really compare it to the current technology.
I understand that Tesla has a half charge long life option.
Sorry,
Has a half charge option to preserve the life of the battery.
So you can set the charge to wherever you want whenever you're actually charging it. So you could choose to always keep it at a lower range, but like most lithium ion, etc., they want to sit somewhere between 20 and 80% for optimal if you were storing it. But realistically, you just use it. So far no one's really killed the battery as such. He's done 45,000 kilometres in the thing, and there's really no reduction or change yet. So so far so good.
Model 3. Can you talk about that?
Model 3, only what I know from the Tesla websites. I'd love a Model 3. Apparently they've just finished the design, as in no more changes, so mass production. Don't work for Tesla, so I don't know any inside information, but Matt's reserved one, I know. A few other people with Model S's have actually reserved the 3 and are going to downgrade, because the Model S is a very wide vehicle, so getting into shopping centre car parks and such is actually a little more challenging than you expect. It looks well in proportion, but it's slightly wider than some of your four-wheel drives, so it's a difficult thing to push around. So Model 3 will be a big game changer. I hope to see a lot more of those, especially here in Adelaide, because they're in a price point a lot more people can achieve. We'll see where it sits with the luxury car tax, because the $35,000 US is going to sit right on that 72,000 marks that the SA government has for the luxury car. So there might be small amounts of luxury car tax, but it depends what you pick, ludicrous and whatever.
Just not so much a question as a comment. The charge rate is around about 100 kilowatts.
Yes, yeah. So apparently some of the superchargers they're working on, they're going to work up to about 125 kilowatt charge rate, so it'll be slightly faster again, but that's what these sit at the moment. So 100 kilowatt into the battery. That's at the lower percentage. It'll drop right off towards the top end. But yeah, that's the idea, that you can charge from nothing to full within about an hour. So you plug in, go have some breakfast, turn around and the car's fully charged. Often he said when he was parking at some of the chargers, he'd go off to have breakfast and his phone would alert him, because the Tesla can alert his phone that it's already fully charged. And so he wanted to be courteous and move the car out of the charging station for other people. So he's still eating his breakfast and had to hurry up because it would charge too quickly. So it's an interesting problem to have.
I was watching the site on and off, but I was amazed by how much it was sort of 80% or more. You know, he seemed to me to be doing fairly long trips, but wasn't using a whole lot of battery.
Yeah, a lot of his trips he would plan because you know, if you wanted to go point A to point B, that was going to be more than the distance, so I had to cut it in half. So he'd only do a 3-hour trip and then just top it up at the next location, like any of us would normally do. You know, you split your journey up into 2-hour or 3-hour trips. So you rock up the next one, just top up the charge, and then away you go. Just keep topping it up rather than completely depleting it, like we do when we drive our petrol cars. You know, in the country, you just fill up at every petrol station because you just don't know what the next one will be, if they're going to be closed or if there's any problems. So same idea, you just keep topping up the electric car. So he would, I think it was only really sort of 30% of his journey he actually had 100% charge overnight. Quite often he was never quite getting there because he had to make sure he left in time to arrive at the next location in time to charge in time. Because unlike your petrol car that only takes 15 minutes to fill tops the whole round trip, this is several hours. So yeah, it wasn't very often that he'd actually get to 100%, but again, you don't need to unless he'd planned full, whatever it is, 400, 500 kilometre journey in that day.
What was the maximum distance he went between charges?
Maximum distance? I don't know that he posted that. I think it was about the 500. I'd have to go back through. As I said, I didn't well prepare for this one. Had a ridiculously busy last couple of weeks, but there would be somewhere in here with his big trips. We find that one where he nearly ran out of juice. That's probably got the it's a bit small to read. Yeah, there'd be somewhere on there, but otherwise, yeah, flick him a message. But he's run the battery too. There you go. It says 0% in the bottom there. That's what we were watching, getting rather nervous. Is he going to need a tow?
450 to 500 k.
Somewhere in there, the Tesla's maximum range with the 90 kilowatt. They're a reasonable range in the S because they've got quite a large battery capacity, relatively speaking, to your Leafs and everything else.
And if you had two motors, you would get less.
I'm not 100% sure on that. Matt was stating the guys with dual motors were actually getting slightly better efficiency because the Tesla was allocating current to the motor that was best suited for the speed you were doing. So it was using the current somewhat more efficiently, but I don't have any scientific numbers. I don't wear a lab coat, so. So yeah, another question?
Did he have to do much fiddling around to get power between Adelaide and Melbourne, or was that all pretty straightforward?
It was relatively alright. A lot of the wineries, interestingly, had some charging points, so it's got some photos there. I think they've worked it out that if you've got an electric car, you probably got some money to spend on wine, so they put little charging stations they could plug into. So good plan there. Sorry? Oh, you're still behind autopilot, yes. No, you're still in control of the vehicle, unfortunately. The police might look at you funny if you're sitting in the passenger seat and the car pulls itself up. It's not quite that ready yet.
He settled at 110, the limit where he could, or 100 where the limit was?
Yeah, so most of the journey sat at the speed limit, but a few of the trips, especially across the Nullarbor, he worked out with his range that it was actually more efficient for him to drop back to 90 kilometres an hour and skip a charging point than it was for him to pull up at 110, sit there for an hour charging and then get to the next destination, because it'd actually take him longer to pull up, charge and then get to the next destination instead of just reducing your speed, because 110 back to 90 in terms of wind loading is massive. So reducing your speed to 90 could then happily cruise along, make the next destination without any trouble. So yeah, an interesting thing to think about. We don't really compute that sort of efficiency in our cars. We just sort of keep cruising along, but you get similar adjustments, but you don't have the granular information that the Tesla can provide. So Yeah, he found, it was only twice, I believe. He found the best way of actually cruising the Nullarbor was up behind a truck, as close as autopilot would let him. But the truck drivers got nervous because they think they'd want to crash into him. But you know, if everyone had CB, you could quite happily pull a number of Teslas up behind a truck very close with the automatic braking, and then you'd be in the slipstream for you know, ultimate efficiency. But until every car's got that, you can imagine a day that everyone pulls out into a highway with the auto range and you can sit really, really close to each other to improve efficiency, like the Tour de France guys, and you know, keep swapping out the leader. That idea. So one day, not yet. So yeah. Anyway, please check out his blog and either follow him or ask him messages, because he's still keen to spread more of the word, even though it's all complete now. He wants more people to attempt the journeys and drum up some more interest for all these little roadhouses, because if they can get more interest and more people visiting, that's more clientele for them, and also helping the cause of getting not only the Tesla chargers, but some more chargers around Australia, because you know, we're fairly light on because the country's so large. Get a little bit envious watching the videos in Germany and Europe, etc., where there's just chargers everywhere. They just pull up on the side of any petrol station or service station and there's another charger there. So nothing like that here yet, but hopefully one day. Yeah, I think Burnside Shopping Village has some in the car park there. Central Market as well. Yeah, they're sort of popping up sort of two at a time, little bits here and there.
So on the way to Melbourne, Stawell's about halfway, or Milton Kniva. It's not one in those towns.
I'd have to check the map. It shows exactly where he stopped. Again, you can look at that on here. The live tracking has all the history data, so you can actually go back through and see exactly where he stayed. And if I can find this map I just had on the screen here, it's actually got...
It seems to lock onto that woman all the time.
Can't get it any bigger, that's not much fun. So you can see... better. So that's where he stopped through the middle there. So Albury down through Melbourne. He actually went down via Mount Gambier because he had some family there rather than going across.
He may have taken the coast road, did he?
Yes, on the way back. I believe on the way there he went straight across, but this map's just showing the way back. So you can see how many times he had to charge, assuming it's big enough on the screen, across the Nullarbor, etc. So he went up via Port Augusta and then could do Port Augusta to Adelaide and trip quite happily, and then spent a couple of days here in Adelaide and then straight down to Mount Gambier.
Can I make a small important point? It's got nothing to do with your talk. The talk tonight's brilliant, but you said something. You said when you come home at night and plug it in, you've got 8 hours to charge it. We've got to get the message into the society that in fact when you're at work for 8 hours, let the sun charge it. That's where the panels should be.
Oh, definitely.
That will stop.
When society will adapt to allow you to plug your car in at work, and the work has roof full of solar panels,
precisely.
then that's the way to go. You charge it during the day when you've got access to solar.
One of the arguments that the power distribution companies are using is we have to super gold plate the grid even more because people come in at night and plug in.
Yeah, which is an interesting point, because the energy companies are actually interested in us all converting to electric to help the base load at night time, because at the moment there's a huge peak and then at night time there's a huge trough. There was a video released on which the Robert Llewellyn does his video series online at the moment, and he interviewed the fully charged, interviewed the London utility companies, and they were actually interested in working with EV owners, getting the grid smarter so that at night time everyone can plug in to keep the load more consistent rather than charging during the day, because it's actually hurting them at night time because there's so much more of a trough with more of this renewable energy and wind and hydro coming on board. They're having to either completely turn off coal, which is great, but then they've got to work out where they can actually put off other energy because there's too much being generated. So definitely plugging in during the day for the solar aspect is a positive, but as these grids get smarter and we've got more of these vehicles being plugged into the grid, they also become a quick hotspot for energy that could feed back into the grid, as well as we're getting more of these smart meters. So we can get to a position where everyone can have their cars plugged in at night time, and if there's suddenly a huge demand for whatever reason, then you could actually reverse draw off your car and sell the energy back to the grid at a premium. So definitely using solar as much as possible, and that's where our power walls and everything else will come into it once the cost efficiency comes down. But it'd be amazing if we could all plug our car in at work, but you know how hard it is to get a car park, let alone find it near a power point. So one day, let's hope. Beautiful. Thank you.
Just a bit of a plug for our meeting Wednesday night at the Vogue Theatre on Belair Road, 7:30. We're having a talk all about the latest in electric bicycles. So that should be interesting. Haven't had that for quite a while. And also at the back on the table as you go out, there's a brochure there for our October EV Festival that we're having. Each year the national branch delegate one of the branches to hold the AGM. And so we had it back in 2010 and it's going to be there again this year in October in Adelaide. So we're having on the Friday we're having a conference, and Saturday is going to be mainly the EV member and AGM activities. On the Sunday we're having a electric vehicle car display in Elder Park. So grab one of the brochures. The conference you will have to book for it. Eventually we'll have booking details on the website. It's not there yet, but I'll bring some more brochures next month and maybe even a month after. Yeah. October's only 3 months away now, so so there we go. Thank you.
If it's anyone's first ATA meeting, please come and see me and get a free renew at the end of the meeting. We won't be having a meeting next month, and in fact we're going to be cutting down on meetings. The strain is getting a bit much, but we'll have another meeting in September. And the FLIR camera, which we have for hire, we've reduced the hire fee down to $10 per week to not to try and make money, but just to try and encourage people to use it to find out where you're losing heat, and in this weather it's ideal. So no more ado. If you'd like to grab a cup of tea and come outside and have a look at Eric's car, and thank you for attending.